So today we're looking at some multi-step equations that have the distributed property in them. So when you're looking at number one, I feel like most of you recognize that you have a number on the outside and you want to distribute that 8. You absolutely can do that. There's nothing wrong with doing that, but you have another option here. Do you remember talking about when we're solving equations and we do order of operations, PEMDAS, but we do it backwards? Right? So first you undo addition or subtraction, then you undo multiplication, division, then you would undo exponents, then you would undo parentheses. So another option, instead of distributing, what I could do is I could get rid of the 8 first, and then, since x plus 3 is in parentheses, undo that last. I don't care which way you prefer. So you can either distribute and then solve like normal, or you can start off by dividing by 8. Are you guys going to distribute, you think?
Yeah,
Well, it's up to you. So, okay, let's distribute this one. We'll do, what do you get when you distribute that through? 8x plus 24 equals 88. And now you're just going to solve it like you normally would, right? Minus the 24. What'd you get? 8. Me too. Unfortunately, they're not all going to be this easy. Okay? So, if we look at one like number 3, this one has distribution going on in the middle of the problem. So, let's go ahead and start by distributing it. So, this negative 8 is just going to stay as it is, but now I have to distribute this 2. So, what comes next? Plus 4, and then plus 12k. Does that make sense to everybody? Where all those pieces came from? So, I'm just leaving that, and then I distributed the 2, and I got here. You could. You could have added 8 to both sides first. Yes, you could have. So now, I have some options. I notice, look at the left-hand side of my equation. I have a negative 8 plus 4 plus 12k. Well, can't I just add negative 8 and 4 together? Yeah, so I could combine like terms here. Negative 8 plus 4 really gets me what? Negative 4. And now I can just solve like I normally would. Now that I've combined like terms on each side. And now go ahead and, what would you do? Add 4 to both sides. Very nice. So I have 12k equals 96. Divide both sides by 12. 96 divided by 12 just so happens to be if you know it. Or if you can reduce it. It's 8. So when you see one like number 5, it's the same idea, but be careful. Everybody watch. See how this is a negative 7? When you distribute that, I want you distributing a negative 7 to both. You follow me? So, you would have 7a, and now you're going to do negative 7 times 6, and negative 7 times 4. What's negative 7 times 6? Yeah, so right there should be a negative 42a. And then, this is such a common mistake right here, is kids will only distribute the 7, not negative 7. If there's a minus sign right there, you're really distributing negative 7 to both. So this next number should not be a positive 28. It should be negative 28. That's a very, very common mistake right there. So just be careful. If there's a negative in front of your number that you're distributing, you're really distributing negative whatever it is, okay? Equals a negative 168 over here. So before I start adding things, adding or subtracting things from both sides, I'm going to try and combine like terms on each side. So if I just look at the left-hand side, isn't there something I could do here? Yeah, I can put the A's together. What's 7A and negative 42A? If I add them together, what do you get? Negative 35A is correct. Now I'm back to a normal two-step equation. So what would you do next? Add 28. So what am I really doing here? The negative 168 plus 28? I really have to subtract. So I can do that in my head, can you? Yes, that's just a 140, and is it positive or negative? Yes. Divide both sides by negative 35, and we should be good to go. I think that comes out to be a positive. Thank you. I get a positive 4. Did you? Did you really? Oh. So I just want to do one more before I let you try some on your own. And it's one like number 19. This one has a double distribution. You got one on the left and one on the right. So the one on the right is actually pretty straightforward, right? I'd have 7, and it's a positive 6, so I just distribute a positive 6, so plus 6n, and then what? Positive or negative? Negative, because it's a positive 6 times a negative 5, right? So I'd have a minus 30 there. Now, please, everybody pay attention to this part right here. Everybody look. Watch. Anyway, look at this side right here. Everybody look. You're actually still going to distribute here, even though there's not a number right there. There really is a secret number.
Isn't it 0, 1?
It's a 1. And not only is it a 1, it's a negative 1. So if I have parentheses, I'm going to have to take whatever's out here, which in this case is a negative 1, and I have to distribute it to both. So, well, this n is still there, right? So that n is there like it was before. But now I have to do negative 1, basically, times n is now negative n. And negative 1 times negative 7 is now positive 7. So if you have a negative outside a set of parentheses, the signs on there on the inside are going to change. So now I have a negative n and a positive 7. Be very careful. Well, good question. What is n minus n? Right, they cancel each other out. So on the right hand side, all I have is 7 because the n minus n is just 0. It's gone. I don't need it. On the left, I can combine like terms. I have a positive 7 and a negative 30. Put those two together. What do you get? Ooh, careful. One's positive, one's negative.
Is it plus 30?
You have
Negative 23.
Yeah, negative 23. And now I solve this like a normal two-step by doing what?
Adding the 23.
That's it. Add 23 to both sides. And n is just 5.